Hello everyone, welcome back to the channel. Today we are going to start the syllabus of lower secondary checkpoint. The first chapter that you have is number and calculations, and then in this chapter we have three subtopics, which is irrational number, then standard writing in standard form, and indices. We will do one by one in different videos. So before we start about these numbers and calculations here, you need to know basics of the things that you will require here. So the first question that I'm taking over here is write a number, write as a number 12 square. You can use calculator. This is just because we are revising this 144, right? And then square root of 81, you all know it is 9. Cube of 5 is 5 times 5 times 5, it is 125, and cube root of 64, it is going to be 4, right? So now you can see these two are related, these two are related. This is square here, square of 12, and this one is 81 square root. This is cube and this is a cube root. Okay, so you see the difference here. Then we will relate these things later. Now 2 power, second question, 2 power 8 is equal to 256. This is given to us. Use this fact to work out the value of 2 power 9. So 2 power 9 can be written as 2 power 8 plus 1. So meaning 2 power 8 times 1. So 2 power 8 is 256, times 2 here, times 2. You multiply, then you are going to get the answer. Similarly here 2 power 7 can be written as 2 power 8 minus 1. 8 minus 1 is 7. So we can split it 2 power 8 into 2 power minus 1. 2 power 8 is 256 times is 2 power minus 1 is 1 over 2. So this is 128, right? So now next we have here is a multiplication, 15 times 5 times 15 times 2. Write the correct number. So whenever we have the base same, then we add the powers. 5 plus 2, it is 7. So the final answer is going to be 15 power 7. So now the next one here we have, write down the answer 15 power 5 divided by 15 power 2 in index form. So then when we have base same and powers different, we subtract it. So this is going to be 15 power 5 minus 2, it is 3, right? Now next we have, look at these numbers. We have 4, negative 4.5, 3000. Then we have 17, 3 over 20, square root 225. So which of these numbers are integers? So now first of all we need to know which of these are integers. Now integers are the numbers on number line. Okay, so here we have number 4 is an integer. This is decimal, this is not integer. Then we have 3000 is integer, and then we have 225 square root is 15. This is also an integer. Okay, now which of these numbers are rational numbers? So rational numbers are the numbers that can be written as fraction. So this is 17, 3 over 20. So all of them can be written as a fraction. Like this can be written 4 over 1. This can be written 45 over 10. This is over 1. Then you continue like that. So that means all. Here this answer is going to be all of them. Write 1 million as power of 10. 1 million is like this. This is 1 million. So if you write in the power, 10 power 6, because we have 6 zeros repeating here, right? So these are the basic things that you have done in the previous years. So that will be useful here. Now starting with our topic here, we have numbers and calculations. As you see, we have 1, 4, 9, 16 are 4 square root numbers, right? So 1 can be written as 1 square, 4 can be written as 2 square, this is 3 square, and this is 4 square. So meaning 1 square, you see here, this is with the diagram, 1 square, then we have here 2 times 2 here, 2 square, this is 3 times 3, this is 4 squares times 4, right? So this is 4 square. So 1 square is 1, and then if you see the opposite of this, square root of 1 is 1. Then 2 square is 4 and square root of 4 is 2. 3 square is 9 and square root of 9 is 3. Square of 4 is 16 and square root of 4 is you see, they are like interrelated to each other. So now what about square root 2? What about square root 2? Is there a rational number n for which n square is 2? Can we write down like something square gives you 2, the way we had here in this? Then you get the square root of that number equals to whatever we are looking for here. So now if you see here we can see that square root 2, if you use calculator, let me tell you to use calculator. If you use calculator, your square root 2 is coming 1.4121356, right? So now you can say this can be written as a fraction. So by definition, the number which are rational, they can be written as fraction. So this can be written as 1421356 over 1 2 3 4 5 6 7 8 zeros, 1 2 3 4 5 6 7 8 zeros. But now the question comes, if I multiply the reversely, like this one, the square root 2 is 1.41213562. If I do the square of this, then do I get the same answer of 2? But you can do that, but we are not getting that. So let me see, what are we getting? This 1.4 it is 1.41213562 power 2. So we don't get this. This is coming 1.99 something, okay, which is not exactly, which is approximately 2, but it is not equal to 2. So meaning then this square root 2 is not a rational number. So then there comes another definition of this, the irrational number. So then what are the irrational numbers now? The irrational numbers, integers, you know that integers are the whole number. For example, 13, 26 and these numbers are integers. You can write rational numbers as a fraction, right? For example, this 9, 3 over 4, this, all these numbers are rational numbers. So before we go to this, like let me show you this 9, 3 over 4, this is 9.75, okay. So then we have negative 3, 4 over 15, this comes out to be negative 3.266 and it continues like this, okay. Then we have 18, 5 over 11. If you do this one, this comes out to be 18 point, you can use calculator, 454545 like this, okay. It continues. Now we have 3 different decimal and they have different properties. So either you can see they terminate or they have recurring. So this is terminating here. Terminating means it ends here, right? This terminates, okay, 9.75. This does not terminate, it is recurring, right? This is recurring decimal. As you can see, 6 is repeating here. This is also recurring because 4545 is repeating, right? So these are the fractions that cannot be written as the these are the fractions that either terminates or they recur. So meaning then that the numbers that are not rational are called the irrational numbers. So these are the rational numbers, so we can still convert them into something called terminating. Then we say the numbers which are not rational are called irrational number. So for example here, let me see show you what are irrational number. An irrational number is a real number that cannot be expressed as a ratio of integers, meaning they cannot be written as the form of a fraction. So for example, square root 2 is an irrational number. We cannot express any irrational number in the form of ratio, meaning in the form of a fraction. In other words, we can put them into fractions, such as p over q, where p and q are integers and q is not equal to 0, meaning we cannot put them in this form. And the condition is q should not be 0. Why this should not be 0? You see, q is in the denominator. If I put p over 0, this becomes infinity, which is undefined. So that's why the condition this q is not equal to 0 is must. Now again, the decimal expansion of an irrational number is neither terminating nor recurring. So this, if you see the square root of 2, when we use the calculator to find out the value of square root 2, it is like this. We have 1.4142136562. It is something like this. None of the digits is repeating here, so it is totally different, which goes beyond the definition of rational number, and we cannot write down this as a fraction. So that's why it is a irrational number. Now irrational meaning that not having a ratio or no ratio can be written in the form of for that number. In other words, we can say that the rational number cannot be represented as ratio of two numbers or as a fraction of two numbers. Now what are the examples of irrational number? The common examples of irrational number are pi. Pi is also 3.14. If you write pi, we have 22/7, but still the calculator value is this 3.145, which is also not repeating. Square root 2, square root 3, 5, etc. These are irrational numbers. Now how do you know a number is irrational? Again, I'm repeating the same thing here. The real numbers which cannot be expressed in the form of p over q, meaning in as a fraction, where p and q are integers and q is not equal to 0, are called irrational numbers. So this gives you the definition of the irrational number. So for example, square root 2, square root 3 are irrational number, where these number cannot be represented in the form of a fraction, right? So numbers that are not irrational are not rational. In other ways, you can say they are irrational numbers. So these are the examples, and these numbers, irrational number that are square root and cube root, are called the surds. Like here these 7 and maybe cube root, usually we write like this with the small cube in here. So these are called surds, right? Now, is pi an irrational number? I think I already explained to you this one. Yes, pi is an irrational number because it is neither terminating nor repeating. Also, pi is not equal to 22/7, as 22/7 the calculator value is this one here. You can see there is no pattern observed, so there are different numbers repeating. So pi is also an irrational number, right? Now let's do some examples. Write whether each of the numbers is an integer or an irrational number. Explain how do you know. So we will do this one by one. And so first part, we have square root 9. Square root 9 is equal to 3. So this can be written as 3/1. So this is an integer, right? He's asking integer and irrational number. So this is an integer. Now part B, we have square root 19. Square root 19 cannot be written as like a square of anything, like 4 times 4 is 16, then 5 times 5 is 25. So this is an irrational number. We will write this is irrational number because it cannot be written as the terminating or recurring. Okay, square root 39 is also irrational. When you take square root 39, the calculator value of this is non repeating and recurring. Now 49 square root 49 can be written as, it is 7 actually, so this is can be written as 3 over 1 as well, so this is an integer. Then E part 99, this is irrational. Let me write down their calculator value so that you can understand more. So square root 9, when you do square root 9, it is 3, you know that. Now square root 19 is it is square root 19 in this case was square root 19 is 4.35889894. you can see this is there is no pattern that is followed here. Similarly for square root 39, let's see, square root 39 is 6.2449998. okay, now this square root 39 7, this is 7, this is integer. Similarly square root of 99 is 9.94987437, like this. Okay, so this is how you can figure it out, right? Now again we have another question here. Write the rational number in this list. So now rational number, as I spoke before, rational number is a number that can be written as p by q form, and q should not be 0, meaning we can, the numbers that can be written as fraction. Okay, so part A so part A, 1 is a rational number. I'm just writing here, this is a rational, then this is also rational, and this is also rational, and negative square root 60, negative square root 60, 160 square root. So square root of 160 can be it is 12.6491106. so this is going to be irrational, right? Now negative 2.25, when you do the square root, it is 1.5 negative, right? So this is also, it can be written as 15 over 10, and then we can write 5 times 3, 5 times 2. I have converted this into a fraction, so this is a rational. So you can go one by one for these numbers. Then square root 35, square root 35 is 5.91607978. so this is also rational, sorry, irrational, because there is no pattern observed and we cannot write this into a fraction. Okay, now part B, write irrational number in this, write the irrational numbers in this list. Now looking at this, you need to know which one is irrational and which one is rational. So here 0.33, it is repeating, 3 repeating, so this is not irrational. So this can be written as negative 4 squared. So square root 200, this is irrational, so we can write it down like square root 2 times 10. So this is irrational number, we will circle this one. So this square root of this is 1.1, so this is rational. 23 over you can see this is already in a fraction form, so this is not irrational. So this is 7, can be written as 7 over 1 in the form of fraction. So the only number which is irrational here is square root 200, right? Now next question we have here, write whether each of these numbers is an integer or a surd. Explain how do you know. Now first one here that we have integer or surd. Okay, so the first one here is square root 100. Square root 100 is 10. 10 is an integer. Okay, so let me do this thing here. This is a number line, right? Numbers on this are 1, 2, 3, 4 and so on. and for the left hand side all. So you see all these are the whole numbers, so these are all integers. Okay, integers are the whole numbers. So this is 10, which is a whole number, it is an integer. So part B, we have cube root of 100. Cube root of 100, it is a surd, because you cannot convert this into a fraction, or you cannot get rid of this cube root here. So C part is square root of 1000. So this is also, this cannot be written, so this again is a surd. So then we have a cube root of 1000. Cube root of 1000 is 10. Okay, so this is a integer, this is an integer. E part, square root of 10,000. Square root of 10,000 can be written as 100 times 100, so answer is 100. So this is an integer, right? Now part F, we have here cube root of 10,000. So if I write cube root of 10,000, you can also use the value cube root of let me show you the other way. Here when you write it down here, it will be 100 times 100, then we are left with 10. So 100 and 100, it will come 100, then we have cube root of 10, so it is still there, so that means this is a surd. Okay, now let's see the next question. Is there in each of the following is each of the following numbers irrational or rational or irrational? Give a reason for each of your answer. So now let's see. Now in part A, we have 2 plus square root 2, right? So here 2 is a rational number and this is irrational. So when you add rational and irrational number, it will be an irrational number, because 2 is irrational. Okay, now part B, we have square root 2 plus 2. Now square root 2 plus 2, 2 plus 2 is 4, and square root of 4 is 2, which is can be written as a fraction. So this is a rational number. Part C, we have 4 plus cube root of 4. So this is irrational. This is irrational because cube root 4 is irrational. Okay, now part D, we have cube root of 4 plus 4. 4 plus 4 is 8, and then cube root of that. So cube root of 4, this is 2, which is can be written as 2 over 1, which is a fraction. So this is a rational number, right? So now I hope you understood the difference between rational and irrational number. Now without using calculator, show that 7 meaning square root 55 lies between 7 and 8. So what will we do here? So we can write it down as the numbers that you are given. So let's say 7, these end points here. So 7 square is 49 and 8 square is 64, right? So the number between this and this, if I take the square root of this, so we will say that 7 square, that 55, I can write down 49 is less than 55 is less than 64, right? So meaning 55 is lying between this. Then we take the square root of every number, square root of this, square root of this, and then square root of 64. Square root of 49 is 7, 55, and then this is 8. So that is how we will prove that 55 lies between 7 and 8. Now here this we have cube root, right? So we will take the cube root of this 7. 4 cubed is 64, right? 5 cube is 125. So 100 is lying between 64 and 125. So I will write down that 64 is less than 100 and less than 125. Now we take the cube root of all these three in the next step. Wait, let me don't use this one here. So this one is 100 and then cube root. Sorry, I have to use this in the next step so that I don't confuse you guys. So then we will take the cube root of all of them. Cube root of 100, then cube root of 125. So cube root of 64 is 4 less than. So this is how we have proved that the cube root is lying between 4 and 5, right? So that's it for this video, guys. I hope you understood about the rational, irrational number and surds. Please let me know in the comment section how did you find this video, and any suggestion for the improvement, and what next topic you are going to you want me to do for your revision. Thank you so much, guys. Be blessed. See you in the next video.